Hi everyone, in this video we are going to be going over lesson 36 for our 8th grade Elevate groups. This lesson is on understanding equations and determining their solutions. As always, before jumping into the actual lesson, we are going to spend the first 5 minutes on the sprint, 4 of which is dedicated to students working through the worksheet, and then about a minute or so of review on certain sets within the sprint. As always, I am going to recommend the 4s, 6s, 7s, 8s, and 9s. So the first part of the lesson is dedicated to understanding equations. We are going to spend 2 minutes going through this intro so we can solidify some vocabulary terms and let students know exactly what we will be working on for the day. So it tells us that an equation can be written to show the relationship between two expressions. On the left-hand side of this equal sign is one expression, and then on the right-hand side of the equal sign, there is the other expression. In a true equation, the expressions on both sides of the equal sign have the same value. So we know that on the right-hand side, we have 21. But then on the left-hand side, we have 12 plus 9. This will be a true equation if and only if 12 plus 9 also equals 21. And because we know that 12 plus 9 does equal 21, both sides of this equation end up with the same value, meaning that it is a true equation. So today when we're going to work with number sentences, you can see the following equality signs. The equal sign that we have been working with for years just means equal. But today, students are going to be introduced to this sign right here, which is an equal sign with a question mark at the top. That means that both sides of the equation may be equal. And then we will also be introduced to this equal sign that has been crossed out in the middle, meaning that both sides of the equation are not equal. So with that in mind, we are going to launch students into a 1-minute turn and talk. Based on the introduction 2 minutes ago, is 4 plus 35 an equation? Why or why not? If not, what is it? So once you launch students into the turn and talk, you will then pull on or cold call 1 to 2 students to share out their answers. By the end of this activity, you should be able to stamp that 4 times 35 is not an equation because it doesn't have an equality sign. What it is an expression. In order to make it an equation, you will have to have 4 times 35 equals 140. So after that discussion question, you will take about 1 to 2 minutes to work on letter A. It says you can determine whether a statement is an equation. Is 20 over 40 equal to 5 an equation? Look for an equal sign. Well, we do see that there is an equal sign, so that's good. The second step is to determine if the expressions on both sides have the same value. We know that one of the values is 5. We need to determine whether 20 divided by 4 also has a value of 5. Now we know based on our skip counts, based on our multiplication sprints and division sprints, that 20 divided by 4 does in fact equal 5. So we notice that the values on either side of the equal sign are equal. So 20 over 4 is equal to 5 is an equation. The second part of this day for intervention, you will be also working on determining solutions of equations. So to solve an equation, we need to find the number that makes the equation true. This equation has a variable a. 3 plus A equals 15. In today's lesson, we are going to substitute a number for the variable to see if the number makes the equation true. The beauty of this lesson is that students have already had a few at-bats with substitution, so they should be able to say, okay, is 12 a solution of the equation? In order to figure that out, I will need to substitute 12 for A in this equation, meaning that instead of doing 3 plus A, I'm going to do 3 plus 12 to figure out whether it is 15. Notice this may be equal sign here because we're not sure whether the number we substituted for A will actually work. However, once we do the math and we see that 3 plus 12 does equal 15, and we note that both sides of our equation are equal, we can go ahead and then stamp that equal sign. So again, new topic, new model. In this model, you are determining whether C is equal to half is a solution for this equation. So when I substitute half for C, will I get 4? So you will have to model that 12 times half is equal to 6. Again, here's that maybe sign. We're not sure whether when we plug in half, it'll work. What we do notice is that 6 is actually not equal to 4, sorry. So substituting half for C resulted in a false statement. C is equal to half is not a solution of the equation. So from here, you are then going to launch students into some independent practice for about 15 minutes while you circulate to support. The first part of their independent practice is focused on determining whether certain solutions work. Students will have to literally do the math in order to figure out whether both sides of the equal sign are the same. And then the second half of their independent practice is dedicated to them utilizing substitution in order to figure out whether an equation is true or false. So for instance, for this example, we have 17 minus A is equal to 12. Substituting 5 for A. If it works, students will say yes. If it doesn't, students will say no. And then the last part of their independent practice is dedicated to them utilizing substitution, but with 3 different options. So they will have to try 5 for W to see if it works, try 6 for W to see if it works, and then try 7 for W to see if it works. For the purposes of this activity, if you think it'll take students too much time to substitute 3 different values to figure out which one works, you definitely can have them work in partners to see who ends up with the correct value